Hello everybody and welcome to your lecture on sedimentary rocks. I have a few sedimentary rocks I want to show you here before we get started. This first one is just gives you a little example of how things change here on Earth. So this is a limestone from the Cumberland Plateau in Tennessee, and if you take a look at it closely you can see probably all those little dimples in there on your screen. All those are little clam shells. Well, not really a clam. It was a creature called a brachiopod about 350 million years ago. And what is kind of interesting about this is that, you see all these clam shells. It shows that obviously this rock formed underwater, right, near the coastline. This one actually was probably underwater, not just on the coast, but under pretty deep water. Well, the Cumberland Plateau now sits 1,400 feet above sea level. So how did that happen? Kind of interesting changes have occurred over Earth's history, right? Another thing I want to point out to you is that sedimentary rocks, they form in layers. So that's kind of one thing that you'll always notice about sedimentary rocks, not all the time, but often, is that they have layers. So if you take a look at this laminated sandstone, lamina means layered. It has, you can see, little layers to it. That's really useful because it shows us what direction was originally up when the sedimentary rock formed. Because, rocks can actually be tilted and folded and all sorts of things. So that's something else that sedimentary rocks can tell us about. It can tell us about the environment, and it can tell us about which way was originally horizontal when the rocks formed. Now this one is a red sandstone. Where do you think you get sand and sandstones forming nowadays? You might be thinking at the beach or maybe in the desert, and that's exactly where a rock like this formed. It formed in a desert. Well, this rock now comes from Ohio, which is hardly a desert, right? So it shows you that environments have changed over time. Sea levels have changed over time, as shown by the limestone, and environments have changed over time, as shown by the sandstone from Ohio. Another thing I want to show you here, just a really dramatic example of layers. I hope this shows up pretty well. I know it's got a really shiny glare on it, but these are layers from what's called a banded iron formation. So this side is not glazed, but this side is. But hopefully you can see the really dramatic red and black. Gosh, it's got so much glare it's hard to see, but I guess that didn't show up too well. Another great thing that fossil or sedimentary rocks tell us about, it tells us about how life has changed on Earth. This is, you've probably seen things like this, but this is a fish fossil from the Green River in Wyoming. And of course we have all sorts of fossils of extinct animals that no longer are with us. So it shows us how evolution and life has changed over Earth's history. This is a really cool one. I hope you like this. You might be looking at this like, what on earth could that be? Well, this is actually from Corpus Christi. This is a fossil from Corpus Christi. What do you think it is? Take a look at it. What could that possibly be? Well, believe it or not, this is actually a tooth. It's a mammoth tooth. So there's another thing. It shows us that climate has obviously changed over Earth's history too. Corpus Christi is hardly a place where you would have expected to get woolly mammoth, right? So it shows you that at a different time in our history, this was a rather cold, maybe like a tundra or something like that. Finally, this is just really neat. Take a look at this. This is just, you might be thinking, oh, well, that's not very impressive. But what's really impressive about this, I just found this in my backyard. So this is actually a Pleistocene. I know you might be looking at that like, what is it? Is it just a rock? No, it's actually a fragment of bone from a large Pleistocene mammal that I just found in my backyard. So once you get to kind of start to recognize fossils, you'll actually find them all over the place. And you might see, how do you know it's a bone and not a rock? I'll show you. Take a look on the inside and you can see that very spongy tissue that is obviously part of a large fragment of a large bone of a large animal. So anyway, those are the things I just wanted to show you before we get started. And keep your eyes out because you might find fossils in your backyard too. They're around here in Corpus Christi. So anyway, I'll switch you over to the normal lecture now. So welcome back. Here's your regular lecture on sedimentary rocks, number 11 here. So I want to talk to you a little bit about sorry, I gotta clean my little pad. I got all that rock dust all over my writing pad here. But I want to talk to you a little bit about sedimentary rocks. So this is a really striking image from Bryce Canyon National Park in Utah, if you ever get a chance to go. It's a really awesome place. These are all sedimentary rocks that you can see in the background that have been really dramatically weathered, which we talked about last time, right? So you can actually see, like I said in the kind of beginning, I have to turn my pen on here. Here, pen, there we go. Sedimentary rocks form in layers. So you can actually see, it's funny how this thing does this. Here, pen, there we go. You can actually see the layers here. Can you all see these things? You can actually see the layers. If you think of the Grand Canyon, right, you can probably imagine how sedimentary rocks form in layers. So those are some of the layers I want to point out. Here's some more. This is sedimentary rocks. Here are the layers that you can see in the sedimentary rocks. So anyway, if it's got layers, it's not necessarily a sedimentary rock, but it probably is. Okay, I got to get my lecture assignment packet here too. I got rocks all over the place now. Okay, so sedimentary rocks. Number one, it says sedimentary rocks cover a large or a small part of Earth's surface. So what you're going to find is they actually cover a very large part of Earth's surface. So often when you go out and you find some rocks, there's not too many of them here in Corpus Christi. It's mostly sand and sediment. But when you actually go out and find real bedrock, it's often sedimentary rocks. They don't make up a large part of the volume of the crust, but they make up a very large part of the surface area of the crust. So number two, I already kind of answered during the sedimentary rock demo in the beginning. But what are some things that sedimentary rocks tell us? I'll go over them again, just in case you didn't catch it during the demo. But first of all, we should also tell you, what is a sedimentary rock? Sedimentary rocks are rocks that are made up of weathering products. So those are the sediments, right? Remember we talked about that already, how rocks break down. It's all the bits and pieces of rocks that have been weathered. And they provide a record of past environments of Earth's surface. So it tells you what was going on Earth's surface in the past. So, like I said, if you take a look at the crust in the Grand Canyon, is a really great place because the Grand Canyon cuts so far down, miles deep into the Earth's crust. You can get a kind of a good idea about how sedimentary rocks work. So you can see the rock layers, right? I hope you can all see the layers. So all these rock layers, you can see so many of them. If you ever go to a place like Sedona, Arizona, where you go to the Grand Canyon, you can see these layers very dramatically. So you can see all the layers of sedimentary rocks that are sitting on top of igneous and metamorphic rocks. Okay, so usually the crust is composed of a large degree of igneous and metamorphic rocks down below. But on the surface, you get a lot of sedimentary rocks that form in these layers on top, kind of like a skin of the Earth. So you can almost think of like the skin of the crust is the sedimentary rock layers, and the flesh and the meat and the bone is all of the igneous rocks and metamorphic rocks that are beneath. Okay, so very abundant on the surface by area, but by volume, very small. So if you think again of your body, most of your body, almost all your body is covered by your skin, right? But is your skin really a big part of your body? Well, it's a part, but it's not a big part, right? Probably most of the weight is muscles and organs and bone and stuff like that. So the sedimentary rocks are just like that skin that forms on top of the Earth. Sorry, I have to have my coffee. You know how I am. So what are some things that sedimentary rocks tell us about about Earth's history? Well, I already talked about this a little bit, but first of all, they tell us about the environment at the time that existed at the time that the rock was formed. Different environments form different kinds of rocks, and we'll talk a lot about that in detail as we go on through sedimentary rocks in this lecture and the next lecture. But you can imagine that, for example, I talked about the sandstone from Ohio, right? Well, where does sand form today? It forms in the beach, and it forms in the deserts, like in sand dunes and things like that, right? So sandstone, it shows you, if you find sandstone, it means that that was either a beach or a desert at some point. And we geologists can actually look closely at different details about those rocks and figure out which one it was. Was it a beach or a desert? Okay, so this one happened to be a desert rock. Okay, and part of the reason we know that is because of the red color. But anyway, more about that later. If we find coal, coal indicates that you are in a coastal swamp. Think of a place like Louisiana or Alabama, where there's a lot of, the bayous and the swamps and things like that. That's the kind of place that someday will form coal. Okay, coal is a sedimentary rock too. Reefs, like coral reefs, which of course we don't see coral reefs, but of course they're around everywhere. There's reefs, and don't have to be coral reefs. It could be like oyster reefs. Here in Corpus Christi, I don't know if you know this, but we have a lot of oyster reefs, right? Well, those reefs form a rock called limestone. Remember I showed you some limestone during the demo. It's this kind of gray colored rock that had all the fossil clams and brachiopods in there. Okay, so anyway, sedimentary rocks tell us about what the environment was like when the rock formed. So limestone, this is very similar kind of limestone to the one I showed you, right? It formed in a shallow sea in kind of like a reef environment. Sandstone comes from sand. It formed in a desert setting or maybe in a beach setting, right? So places that sand is deposited today. Okay. Now another thing I mentioned is that I showed you, remember how this limestone, we found this in the Cumberland Plateau that was 1,400 feet above sea level today. So if something is so high today, such a high elevation today, how was it below water at a different time? Well, it shows you that sea levels have changed, and also the elevation of Earth has changed over time, right? So, for example, during the late Cretaceous, during the age of the dinosaurs, right, there was a vast inland sea covering a lot of North America called the Sundance Sea and the Intercretaceous Seaway. There are two different seas that existed at two different times. So it shows you that sea levels have altered. Sea levels have changed. It also shows you, like I said, showing you the woolly mammoth tooth, right? That climate has changed. This is in Corpus Christi. Can you imagine a woolly mammoth walking around Corpus Christi today? Well, I guess I could, but it shows you that climate has changed. So, this is a whole record. This is what you're seeing right here is a record of climate over millions of years, right? And how do we know that climate has changed over the millions of years? We know it from sedimentary rocks. And if you ever want to get into all the juicy details of that, you have to take historical geology. I explain all about how we know about how climate has changed. A lot of people are concerned about the climate today. Well, how do you know if this is normal part of Earth's history or Earth's patterns, or how do you know if it's anthropogenic and caused by humans? Well, you got to look at the history, right? And the history of climate. How do you know that? From the sedimentary rocks. Okay, so sedimentary rocks tell you about climate of the past. Okay, now like I said, sedimentary rocks also tell you about one last thing I should have mentioned too, is it tells you about past life, right? The fossil life. So there's all sorts of fossils we find. Obviously, dinosaurs are one prominent example of animals that used to exist that no longer exist. So it shows you about life history and how life has changed on Earth over time. Okay, so that's number 2. I answered number 2 now. So sedimentary rocks form in layers called strata or beds. Okay, so these layers that you see, we call them beds or strata, either one. Okay, so sedimentary rock beds, sedimentary strata. And you can see all the different kinds of sedimentary strata that are formed in the Grand Canyon, and of course these exist all over the world, except the Grand Canyon is just a great place to see them because it's cut so deep. The canyon cuts so deep you actually see all the different layers. If we had a deep canyon here in Corpus Christi, we'd see the same kind of layers, right? So they're under our feet, but we just don't see them. And by the way, just kind of let you know, we usually give these rock beds certain names. So for example, in the Grand Canyon, there's the Kaibab limestone, the Supai group, Red Wall limestone, Hermit, all these different things. Bright Angel shale. We give all these names to all the different rock layers that exist. Okay, so that's how we geologists keep track of all these beds. Okay. Now, sedimentary rocks often form in water, and they form from because water's depositing the sediment. It's causing the weathering. It's causing the erosion. We usually get water depositing a lot of sedimentary rocks. So when the water levels, like I said, water levels can rise or fall. When they rise, we call that a transgression. Okay. When they fall, we call that a regression. Okay. And when the sea levels rise and fall, it actually creates a certain series of rocks. So limestone is deposited in very deep water. Shale is deposited in kind of less kind of water, but sort of shallow marine water. And, silt and sand is coastal, like where you might have a delta or like a beach, okay? So when we see, sandstone on top of shale, on top of limestone, what does that mean? Well, that means that the water levels have actually been, sinking, okay? So the limestone formed when the water was deep, and then on top of that formed the shale when it got shallower, and on top of that formed the beach sand when it got very shallow. Okay, so those are transgressions and regressions. So just explaining more about what sedimentary rocks, all the details about what sedimentary rocks can tell us about Earth history and the history of life on Earth. Okay, so let's get now into number 5. We're going to talk about the different kinds of sediment. So sediment can be a lot of things that form sedimentary rocks. One thing that it can be are loose fragments of rocks and minerals that have broken off of the bedrock. So that's that stuff that gets weathered off of the rock, forms in like a talus slope here. Remember we talked about talus slopes when we talked about weathering. Okay, so all this stuff, all these broken rock fragments, all that is sediment, and if it someday gets compacted and turns into a sedimentary rock, right? That would be one form of sedimentary rock called a clastic sedimentary rock. So I'll write that here. So if you form like this from loose fragments of rocks or minerals, you're clastic. Okay, it's called a clastic one. That's one of the 4 categories. So you can put that down for number 6. First category is clastic. So the sedimentary rocks that form from broken fragments of rocks or minerals, we call those clastic. Now, another kind of important rock are biochemical rocks, okay? So sedimentary rocks, this is something you put down for number 6, biochemical. Biochemical are formed from the shells or shell fragments of marine organisms, okay? Now, a lot of shells, I'm sure when you think of shells, you're thinking of like clam shells, things that you can see with your eyes, oyster shells and clam shells. But I just want to let you know that there are so many shells that you cannot see that are smaller than what you can see. They're actually formed by planktons, various kind of plankton that are microscopic, and so they make little shells. I'll show you some pictures later, and they settle to the bottom and form biochemical rocks such as limestone. So remember this one I showed you. Remember that gray limestone rock filled with clam shells, right? So that's a very good example of a biochemical rock. Okay. Now, we can also have minerals that precipitate out of the water. I can give you a good example of this. I have a piece right over here. I'm going to pause this for a second. Okay, I have my chemical sedimentary rocks here. So this one here is gypsum. So you can see this is actually kind of clear, right? So you can see me looking at you through this gypsum here. And this other one is actually rock salt. So it's actually salty and you can taste it. You can take a look at the picture right here of the Boneville salt flats in Utah. This is all salt. Isn't that crazy? Look, as far as the eye can see, it's just salt. So the salt is precipitated out of evaporative kind of environment. And, whenever you have water, you have a lot of dissolved mineral content. I'm sure you know that here in Corpus Christi, water has a lot of interesting dissolved things in the water. And when that stuff dissolves, precipitates out, it can form sediment and become a sedimentary rock. So gypsum and halite, rock salt, are two very good examples of that. Okay, that's all things that precipitated out of the water and formed some kind of sedimentary rock. All right. Now the final thing, I have A, B, C here, but the final thing you should know is also organic matter can become compressed, and it can become what's that word? Heat distilled. It's called heat distillation, but it's a way of turning organic matter into a rock. And the very prominent example of that is coal. And I'm sure you've heard of coal before, and lots of coal in Texas. And that's another thing, is organic matter can also become a rock eventually and become sediment as well. All right? So that's what you need to know for number 5, the 3 different kinds of sediment. And I guess you could put number 4 there and add organic matter. And those correspond to the 4 basic categories of sedimentary rocks for number 6, okay? So you can have, just to go over them again, you can have clastic if it's forming from rocks and minerals. You can have biochemical if it's forming from the shells of marine organisms. Or you can have chemical, I forgot to write chemical here, if it's forming from direct precipitates out of the water. Okay. The last thing you can have is organic matter, which forms organic sedimentary rocks. Okay. So those are the 4 categories of rocks and the 4 kinds of sediment that correspond to them. Okay. Chemical weathering. Just want to remind you about chemical weathering and physical weathering. Weathering is what breaks rocks into smaller pieces and creates the sediment for sedimentary rocks. Okay, remember we have physical weathering, we have chemical weathering. We talked about that in the previous lecture, so that's just a little bit of review. Remember we have different weathering processes like jointing, we have like frost wedging. These are all things that create the sediment, create the clasts that become clastic sedimentary rocks. Okay. Now, with sedimentary rocks, clastic sedimentary rocks. Now we're just talking about clastic sedimentary rocks here. We have different clast sizes. So this is number 7. I'm asking you about different clast sizes. Okay. So these are the clasts. We have the smallest kind is mud. Okay. Sometimes people call it clay. Mud or clay. This is stuff that is way below the threshold of what your eye can see. So you could actually do like to actually see these, you would need like a scanning electron microscope. I'm gonna bring up. I could probably just bring this up and show you SEM images, scanning electron microscope images of clay particles. I forgot I should put this in the lecture, but I just kind of wanted to show you what this looks like. So, you need these scanning electron microscope. This is a really good picture right here because it shows you kind of the flaky. But these are so small, you can't see them with the naked eye, right? So that's the point here. A little bit bigger, but still invisible to the naked eye is silt. Okay, silt is kind of gritty. You wouldn't be able to see it. It wouldn't look like sand, but it'd be kind of like a gritty mud, if you could imagine that. We also have sand. I'm sure you know what sand is. I'm not going to explain what sand is. We have pebbles that are a little bit bigger. Pebbles are smaller they're between 2 millimeters and 64 millimeters. 64 millimeters would be 6.4 centimeters. So it'd be kind of like, hand sized. Okay, so like this would be the largest thing you could possibly have for like a pebble. What would be called a pebble. Things larger than pebbles, we call them cobbles. Very rare to find a sedimentary rock composed of cobbles or boulders. It does happen, but it's pretty rare. Most things are going to have sand, silt, and mud, honestly. The vast majority of sedimentary rocks are made of either sand, silt, or mud, or some mixture of those. Okay. So that's number 7. Those are the different kinds of class sizes. Now, that's important to understand because this is how we classify clastic sedimentary rocks. We classify clastic sedimentary rocks based on particle size, clast size. Okay, and I'll show you more about that later. All right, so moving along. Oh yeah, I want to talk a little bit about this too. About, I wanted to show you this. So you remember Bowen's reaction series? Bowen's reaction series is so important because it not only is important to igneous rocks, it actually comes up in metamorphic rocks, you'll see later, and it also comes up in sedimentary rocks as well. Because, guess what? Remember about Bowen's reaction series and the amount of silicate interconnectedness? Okay, well, take a look. This is a list of minerals in order of what erodes and weathers most easily versus what weathers and erodes with most resistance and most difficulty. Okay, so when you have different, let's just say you had a big grab bag of different rocks, okay, and they're going to start to be weathered, right? Rain and sleet and snow and wind are going to be blowing on them. What's going to get destroyed first? Halite and calcite get destroyed first. Okay? Halite and calcite have no silicate, right? They're non-silicates. Non-silicate. Non-silicate rocks, often, not always, but often are not very hard. Okay? There's exceptions to this, of course, but they're often not as hard. Silicate rocks are real tough. Those silicate molecules, when they interconnect, very tough. All right, let's look at the silicates. What's the next thing to weather and break down? Olivine. Okay? So olivine, calcite, halite. What's the next thing to break down? Calcium-rich plagioclase. Remember the continuous series? Calcium-rich is the first to precipitate out under Bowen's reactions, continuous Bowen reaction series. Okay, followed by pyroxene, followed by amphibole. Okay, so all this stuff, maybe about right here, all these minerals, you can put that for highly susceptible to weathering. Well, isn't this kind of cool? Look at this. Olivine, calcium-rich plagioclase, pyroxene, amphibole, sodium-rich plagioclase, biotite, orthoclase, muscovite, I'm going to skip clay, quartz. That's the Bowen's reaction series, right? It's the continuous and discontinuous Bowen's reaction series. So it's really kind of cool because it shows you that the Bowen's reaction series also plays out in how hard it is or how easy it is to weather a mineral. Okay, quartz is the toughest, followed by muscovite, orthoclase, biotite, plagioclase, amphibole, pyroxene, finally olivine. And they're all in order of that, what? Silicate interconnectedness. The more interconnected or how disconnected they are, right? Olivine doesn't have all those silicate bonds, so it breaks down very easily. Okay, so those are things right here that are very easy to erode. Things here, maybe you could say in this category, amphibole, plagioclase, biotite, orthoclase, muscovite, are maybe mildly susceptible. And then things like clay, quartz, gibbsite, and hematite are the most stable. Okay, so those are things that you can put for answer number 8. So that becomes really important in the next lecture when we talk about chemical maturity. This becomes very important. So I want you to remember this. Maybe you should write down right there for number 8. Just write down this has to do with chemical maturity. Okay, and we'll come back to that concept later in the next lecture. Okay, so let's talk now about how you make a sedimentary rock. There's 4 steps. Number 9. I want you to please describe these steps. You know, when I grade this, I'm going to be making sure that you're describing, not just putting a word down. Please don't put down just a word. Describe, put a sentence there. I know you don't have a whole lot of space, but write small and try to put a sentence down there. Just describing each of these steps, okay? So this is how we make a clastic sedimentary rock. This is how we make a clastic. And I really should have put here how to make a clastic sedimentary rock in 4 easy steps, okay? All right, first step is weathering, right? You create the clasts. Weathering creates the clasts. It breaks down the bedrock and it makes little pieces. Well, I guess they're not always little. Sometimes they're kind of big, but it makes little pieces. And the little pieces are what are the clasts, the particles that will get cemented together ultimately. Okay, remember when we have those 4. Why do I have 4 up? We have 6. We have 6 different class sizes. Those are clay, silt, sand, pebbles, cobbles, and boulders. Okay, and that's going to determine how we name and categorize the clastic sedimentary rock. We categorize it. Clastic sedimentary rocks, we categorize it on the basis of clast size, particle size. Okay. Next step, transportation, what is also called erosion. Erosion is when you remove all of the sediment. You transport the sediment. So there's a lot of different things that can make sediment move. Okay, it's not just water. Water is one of them. Of course, you could have water eroding, but there's other things that can erode too. Wind can erode. And also another thing I want to point out that probably you never even thought of, glaciers can erode. Actually, glaciers erode like crazy. There's actually nothing that really erodes quite as destructively as glaciers. Glaciers are the worst. And when we have a lecture on glaciers, you'll learn a lot of really surprising things about them. They're pretty interesting. Okay, so The third step is deposition. So once we take all the weathered products, all the clasts and particles, they get eroded, they get transported somewhere. They're either blown by the wind, carried by the water, or they're carried by the ice in the glaciers. They're going to get deposited somewhere. Now, usually where it gets deposited is something called a basin. A basin is a low-lying area. Think of like a valley or something like that. It's a low-lying area, and it's kind of the final stop for the water or the wind or the ice. Okay, so it brings it to a low-lying area. So these are this basin here. You can see like in the mountains, the water's flowing out of the mountains, and it comes to a valley, and then it dumps all of the sediment at the mouth. And makes something called an alluvial fan, because it's kind of, you can see it's kind of fan shaped. Okay. Sometimes the water brings it out to the ocean, and you form a delta, right? So delta is another place where things get deposited. Sometimes you have glaciers. The ice carries the sediment out from the mountains down into low-lying areas, and it creates these hills of sediment called moraines. Or sometimes wind blows sediment, and it creates things like dunes. Or if they're made of sand, we call them dunes, like sand dunes. If it's made of silt, we call them loses. Okay. So those are all just kind of different sort of forms of sedimentary deposition, classic sedimentary deposition. Okay. Now, the final thing you have here is step 4. The last step is something called diagenesis, or AKA lithification. So what is diagenesis? Diagenesis is, get ready for this is number 10, right? Diagenesis is a series of processes. Diagenesis is a series of processes that turn sediment into sedimentary rocks. Okay? What are some of those processes? Okay, because I just kind of said vaguely processes, things that turn the sediment into a sedimentary rock. What are some of the examples of that? Well, you have compaction. Okay, so the water and air bubbles, the spaces between the sediment get pushed out, right? So the sediment gets compacted. Okay, so compaction. You have eventually what's something called dehydration. So the water gets pushed out. The air gets pushed out. The water gets pushed out. It's called dehydration. And finally, you have lithification. Lithification is when there's so much pressure pushing the grains together that they start to dissolve and fuse together, and or sometimes they get cemented together. Okay, there's different ways of getting the grains to stick together. There's cementation. There's pressure solution. Two different things. We talked about pressure solution in metamorphic rocks, but anyway, that's what creates the fusion of the particles together and finally makes a sedimentary rock. Okay. So that's it, in a nutshell: weathering, erosion, transport, deposition. Okay, that's how you make sedimentary rocks. So let's now move on. Number 12 here says we're just going to look at some of the different sedimentary rocks, and you're going to learn their names. Okay, so learn all the different kind of sedimentary rock names and the 4 categories, right? So we're going to learn sedimentary rocks in the 4 categories. So first category we're going to talk about is clastic rocks. Okay, so the clastic rocks. So let's talk about this. Clay, remember we named clastic rocks on the basis of particle size, right? So if you're a clay, you undergo diagenesis, you become shale. Notice how shale is very sheety. It splits into sheets. So if you're taking the lab, that's how you're going to recognize shale. As shale splits into these sheets. Okay, silt, when it forms, siltstone. Okay, very easy to remember, right? Siltstone. Sand forms sandstone, right? So that's pretty easy to remember. Now, if you have a mixture of pebbles or cobbles with other stuff, because what happens is you don't ever get rocks that are just purely made out of pebbles and cobbles. And the reason is that there's going to be a lot of pore space in between those pebbles and cobbles, and that's going to get filled with something like clay or mud or something. So you're always going to have a mixture, okay? So well-rounded. So if the sediment is well-rounded, okay, so you can see how these pebbles here are more round compared to these ones, which are more angular. Okay, we call it a conglomerate if it's well-rounded. If it has broken sort of fragments, like sharp angular pieces, we call it a breccia. And the reason that we give it a different name is because it forms in a different way. So conglomerates form when you have, like, maybe they can form in a few different ways, but it can form from glacial deposits and it can form from stream deposits, whereas these very angular pieces, like from a breccia, form during like landslides and mass wasting processes like that, like landslides. Okay. So those are the clastic rocks. The biochemical rocks are the limestones and chert. And there's a few different kinds of limestone we'll talk about. Okay. Now, remember I told you that there's so many. So these are rocks that are formed from the marine life, basically. The shells left over from marine life. Sometimes you can see the shells, okay? But more often you cannot see the shells because they're so small. Now, whether you know it or not, I always kind of took issue with, SpongeBob SquarePants in that show with Mr. Plankton, because Mr. Plankton really should have had a shell, because a lot of plankton does have a shell. So this is a very good example of plankton that's scanned with it's called a scanning electron microscope. It's a very, very powerful microscope that can see things that are actually smaller than light, but light waves. Okay. So these are things you could not see with a normal microscope because they're so small. I just find this crazy. This beautiful little exquisite shell you see there is so small, it's smaller than a wave of light. So you can't see it with light. You need a electron microscope. It's an imaging tool that fires a little gun of electrons to scan, and image whatever target it is. Okay. But anyway, this thing is it's a little shell left over from plankton. It's called a coccolithophore. And it's just so amazing. You have these white cliffs of Dover here, right? Just 400-foot tall cliffs of chalk. And what is it made of? It's entirely made out of trillions upon trillions of these things. Coccolithophores. Little tiny shells, smaller than a wavelength of light, of these little planktonic organisms. And they die, and their shells sink to the bottom of the ocean, and they build up over millions of years, and then you got 400-foot cliffs, kilometer thick beds of sediment. So it's amazing. It's just mind-blowing. Now, when a biochemical rock like a limestone is made out of visible shells, big shells that maybe you see at the beach, we call that a coquina. And this is actually one of the few rocks you can find in Corpus Christi. So down by the beach, I know that I've been, if you go to Indian Point over on like Portland side of the bay, you can actually find coquina rock there. And it's unsurprisingly made out of oyster shells because, there have been oysters here in Corpus Christi for a long time, for millions of years. So you find oyster shells, right? When you have calcite-rich mud and shells, we call that a phospholiferous limestone. Okay, so this actually, what I've been showing you during this class, this from the Tennessee Cumberland Plateau, this is actually a phospholiferous limestone. Okay, it's made out of like a calcite-rich mud that forms in like coral reefs and things like that. Okay, chalk, the chalk that you write on a chalkboard with, actually a rock. Okay. And it's actually made from, like I said, these beautiful little planktonic organisms that are smaller than light. They have beautiful little tiny shells that are smaller than a light wave, called coccolithophores. There's all sorts of, by the way, plankton is it's a huge subject, okay? I could go on and on about plankton. If you want to hear me go on and on about plankton, you can sign up for oceanography. We talk a lot about plankton. But anyway, so that chalk is another kind of biochemical rock. And there's another biochemical rock called chert, which is not made of calcite, calcium carbonate. It's actually made of SiO2. And it's also made out of the small little bits of shells of marine organisms. Okay. For organic rocks, what can you put? Coal. and oil shale. Those are things that have a lot of organic matter in them. Okay, coastal swamps. Think about, like I said, Louisiana, Alabama. You get the perfect environment to form coal. Okay. Final group are the chemical sedimentary rocks. Chemical sedimentary rocks are rocks that are composed of direct precipitates from the ocean or from a body of water. So rock salt, halite is a good example. You could lick this. I already did. And I won't lick it again. But this is, right, a pure rock salt, right? Forms from precipitates out of the ocean. Gypsum, right, forms from precipitates out of the ocean too. This is calcium sulfate. So there's a lot of calcium, there's a lot of sulfate in the ocean, believe it or not. The Dead Sea, you've probably seen pictures of the Dead Sea. It's a very, very salt-rich body of water, right? And you could see salt literally building up on the shore of the Dead Sea, okay? So things like travertine, gypsum, halite, dolomite, these are all different forms of chemical sedimentary rocks, okay? So there's just, again, gypsum, halite, dolomite, they're all just examples of sedimentary rocks, chemical sedimentary rocks. Okay, so I gave you a lot of different things you could put down for number 12, and I already answered number 13. Okay, we already talked about that. And for number 14, that's the last thing we're going to talk about. Okay, is different, what are called depositional environments. So I want you to know something about, for each of these kinds of rocks, I'll give you A through F, what's the depositional environment? Okay. So we're going to go through these different kinds of depositional environments so you know where do these different kinds of rocks form. And what does it tell you? If you find this rock, what does that tell you about what the environment was in the past? Okay. So easiest one I think for us here in Corpus is a coastal environment. What do you find at the coast, at the beach? Not rocket science. It's sand, right? So what kind of rock forms at a beach? Well, it's going to be sand, gives you sandstone, right? What about here? Another thing we have a lot of in Corpus. What about reefs? Okay, we have a coral reef. This is a very dramatic picture of a coral reef. We don't have so much. Well, of course, we do have coral reefs here actually, but we have a lot of oyster reefs too. Reefs will turn into a limestone. Okay, so whenever you have a reef, you get a limestone. You can probably see, if you look at the picture of the coral and then you look at the limestone, you can see all the coral preserved in the limestone. Okay, so it looks kind of like a picture of what was there at the time in real life, right? It looks like a picture of the reef. What do you get at a coastal swamp? I already said coastal swamp, you get all that organic matter, gets compressed, and by heat distillation turns into coal. Okay, so diagenesis turns that organic matter of a swamp into coal. What do you get at a delta? Delta is when you have a river bringing in, depositing all this sediment into the ocean or into a lake. And you get siltstone, shale, sand. You get a big mix of mud and clay and sand and silt. So you get all sorts of rocks like that. Siltstone, shale, sandstone. Usually you get them kind of interlayered with each other. Okay, so that's what you get at a delta. What do you get in a desert environment? You often get red sandstones. Often you get red sandstones that have something called cross-bedding in them. We're going to talk about cross-bedding. So you might have seen pictures. If you ever go to a place, again, like in the Arizona, you'll find a lot of rocks like this that have, can you see the layers here? And they're kind of like tilting like this. That's called cross-bedding. Okay, we'll talk more about cross-bedding in the next lecture. But all of that is from the formation of sand dunes. I'll show you later in the next lecture how sand dunes give you cross-bedding. How about inland lakes, saline lakes that are like desert lakes, like, for example, Salt Lake City, or think of the Dead Sea. Okay, those are very highly evaporative environments. The water's very salty, and it starts giving you things like gypsum, right? Doesn't that look like the gypsum I've been showing you, right? I've been holding up to this, keep holding this up to the screen, right? You get things like gypsum, you get things like rock salt, and that's what so that's the kind of rocks you get from kind of interior lakes or highly saline lakes. Okay, so I answered all your questions, and I wish you a good week. And we will continue talking about sedimentary rocks in the next lecture with sedimentary structures. So have a good week, have a good weekend, and I'll talk to you next time.